Your guide to PCB design basics and steps. If you are new to PCB design, it may be helpful to review the basics of the circuit board layout. We will go over the most important PCB design rules and how to balance your trace lengths and components on a board. You will also need to know which components you should isolate to keep their temperatures low. For example, you should separate high-power components from each other to even out their temperatures. To calculate this, look up the thermal resist rating of the component. You can use this information to decide whether you need to use heat sinks or cooling fans to cool them down. The stack-up definition is a fundamental component of PCB design. It describes the physical structure of the multi-layer circuit board, such as the amount of copper used in each layer. It is vital for manufacturing the circuit board, as a correctly stacked board helps minimize crosstalk and electromagnetic emissions. This also improves signal integrity. Stack-up also defines how there is interconnections of components. For example, if traces are too close to each other, they can lead to a poor signal integrity. Placement is another key step in PCB design. It involves strategic assessment of the board's real estate to minimize layers transitions. Placement should adhere to specific design rules to ensure optimal routing. You must follow several design principles to avoid mistakes. Make sure that component placement is within the specifications required for the printed circuit board. For example, a PCB design should be 0.02 mm larger than its nearest neighbor. You can construct a PCB design with fewer errors and a lower cost by following these guidelines. PCB Design Resources. There are many resources to help you with PCB design. You can attend blogs and industry conferences to learn the ins and outs of design and production. You can also hire a PCB contract manufacturer for design, engineering, and manufacturing expertise. These firms can help you explore new technologies and help you overcome common design challenges. They will also provide you with specialized components and services. You should always have a budget cushion. A PCB is the heart of any electronic gadget or electrical device. High-speed electrical connectivity is essential. Integra Sources can help you with every step of the design process. With their dedicated hardware engineers, you'll control costs and scale your project accordingly. No matter what type of electronics product you're building, you'll need a PCB. Integra Sources' comprehensive solution for PCB design includes PCB layout and design consulting. CAD software and Gerber Viewer are two of the most essential PCB design resources. These software programs are indispensable in the process, and most of the time spent in the CAD phase is spent on PCB layout. In addition, Mentor graphics pads and Orchid Capture are industry standard tools. These resources are especially helpful if you are just starting out. However, the resources mentioned above are not exhaustive. You can find many more PCB design resources, including books and blogs. Consumer electronics require small PCBs with high-volume connections. In addition to this, consumer electronics require low-cost PCBs. However, despite the high demands of PCB design for these products, these manufacturers need reliable boards to make their products function well. With the help of PCB design resources, your medical devices will become more advanced and functional. The medical sector is continuously coming up with new uses for electronics. As technology improves, the possibilities for smaller, denser boards will increase. Your guide to PCB design basics and steps. PCB design is a complex process that requires careful preparation, which is why your guide to PCB design basics abounds in valuable advice. It starts with a schematic, which is the electrical design but has not yet undergone translation into a mechanical representation. The schematic capture tool will create a PCB layout based on this electrical design. The schematic capture tool is essential for PCB design because incorrect symbols make the entire process difficult. When designing a PCB, you'll first want to decide the size of the board. The enclosure that houses your PCB will often be the largest limiting factor. Besides enclosure size, component selection can also affect the size of the board. For example, surface-mounted components have a low profile, so they can be made smaller. By contrast, through-hole components have larger footprints and are easier to find and solder. The layout of your PCB will depend on where you'll place the components. For example, suppose you're designing an audio amplifier. In that case, you may want to place the power switch near the volume potentiometer so that the LED will indicate whether the power switch is on. However, larger circuits are more complex, and a single copper layer may be insufficient. Often, 2 copper layers will be necessary, and traces will need to be routed on both sides of the board. Once you've made your PCB layout, you'll need to print it out. Remember that these blueprints don't print on an 8.5 by 11 sheet of paper, but on a plotter printer. This plotter printer prints the PCB design as film. This film is similar to the transparencies you might have seen in school. It's like a photo negative of the board. Remember that clear ink represents copper pathways, and black ink indicates areas you will remove. General considerations on high-power PCBs. If you are planning to design a PCB for a high-power device, there are some general considerations that you need to consider. These factors can be crucial to ensure that the board is designed correctly and functions properly. In this section, you will learn some of these important tips. Also, you will learn how to design high-power PCBs. Keep reading to learn more. Below are some of the most important factors to consider when designing a PCB for high-power applications. First and foremost, the PCB design should incorporate fuses and other safety features. Fuse holders are important for protecting against short-circuiting, but you should also consider other design features. For instance, you should consider the manufacturing process of a PCB and the quality of the materials used to produce it. In addition, a high-power PCB must withstand the voltage applied to it. Moreover, a high-power PCB must have a fail-safe firmware that can detect the increase of temperature. Moreover, the PCB design should contain components with low resistance to avoid short-circuiting, which poses a risk for a human. The number of years in the PCB manufacturing business also determines the quality of high-power PCBs. Experienced manufacturers will probably be equipped with the necessary equipment and manpower to produce high-power PCBs. Nevertheless, not all PCB manufacturers can fabricate high-power PCBs. Similarly, companies with limited prototyping and production facilities may not have the manpower to handle these complex PCBs. Considering all these factors, it is best to find a company that can provide both. PCB surface finish type. PCB surface finish types include tin, gold, and immersion. Immersion tin is the most affordable type of immersion coating, but it does have a few disadvantages. For example, immersion tin is not compatible with projects that require a removable solder mask. This type of surface finish is also not very popular for small quantities of PCBs. Listed below are the pros and cons of each surface finish. The importance of PCB vias. PCB vias are the most important part of your design when it comes to manufacturing. Vias are a simple pair of drilled holes separated by a pad. Sizes of the holes and pads depend on the size of the board. Smaller vias are more flexible, allowing more space for traces, but they also cost more. Therefore, during the layout stage, you should take time to plan the via design and submit it to the factory. PCB manufacturing requires the use of vias in order to make electrical connections. These holes are drilled with certain tolerances, and you may also manufacture them off location. Therefore, allowances for drill position errors are necessary before manufacturing. Without proper vias, manufacturing yield is reduced. In addition, regular through-hole vias must be plated. Various processing steps are needed to ensure that the through-holes are plated properly. The result is a layer of thin orange and gray materials that makes the electrical connection. PCB vias are made with several different types of materials. In addition to conductive material, they can also be made with a copper core. The first type is made of copper. It is essential when the board must be a high reliability product. Another type is made of plastic. Plastics are generally more expensive than metal, and may be more sensitive to abrasive materials. PCB vias are available in a variety of shapes, including circular or angled vias. How to learn PCB designing. If you have been thinking about becoming an electrical engineer but haven't had the chance to learn PCB designing, you're not alone. Electrical engineers need to know how to create circuit boards for many industries. While their educational training may not have focused on PCB design, there's a need for young, creative designers to join the field. In addition to the manufacturing industry, PCB designers are needed in various R&D groups and industries across the world. Once you get enough experience and the right skills, you'll build a career in a variety of different fields. If you're unsure of where to start, you can always try an online course. To learn PCB designing, you need to know the basics of PCB composition and the use of an ADA software. PCB design can be a lucrative career for engineers who are skilled in using ADA software. With enough motivation and practice, you can become an expert in the field. You need a good ADA software package and a willingness to learn. You can also start from scratch by following a tutorial or two. What is artwork in PCB designing? PCB designs need to be based on the correct artwork. We use this artwork to create the pattern of printed wires and components on the board. It is similar to printing plates, but is only vaguely related. The artwork will define the size, orientation, and composition of the board's components, solder pads, and lands. It must also show true to scale measurements and any scaling level that is required. Advantages of surface mount components in PCBs. Traditionally, electronic components were mounted and soldered into place on circuit boards. These electronic features included transistors, resistors, and capacitors. While it was possible to place these components manually, most manufacturers today use special machines. These machines create more accurate, high-quality results. Here are some of the reasons that manufacturing companies prefer surface mount components. First, they are much more compact and flexible than wired components. This makes them ideal for automated pick-and-place machines. A typical PCB contains several types of surface mount components. The first type is a resistor, while the second type is a capacitor. Resistors are small rectangular chips with or without numbers. A common surface mount package size is 0603, 1608 metric, while a ferrite bead is slightly larger at 0805, 2012 metric. On the other hand, a MOSFET transistor is about the size of a British postage stamp. Another option is the use of through-hole technology. This type of technology uses holes instead of a drilled hole in the PCB. The result is a much more accurate surface mount product. Using this technology has many advantages, including reduced cost and increased reliability. For example, it makes it easier to automate assembly and soldering, which increases the productivity of electronic devices. And unlike through-hole technology, a PCB with surface mount components is much easier to manufacture. As far as the size and weight of surface mount components is concerned, they are usually smaller than their lead-based counterparts. This makes them easier to handle and transport. Using a machine to handle them is also easier, as the leads of SMT devices are typically a lot smaller. In addition, the shape and size of these components are standardized in the electronics industry by the leading standardization body. How to design a PCB layout. If you are wondering how to design a PCB layout, this article is for you. If you've never done it before, you'll be glad to know that it's not as complicated as it looks. Whether you're a newbie or a pro, there are several things that you should know. Follow these tips and you'll be on your way to designing your own PCB. First, you must decide which components you are going to place on the PCB. For example, you might place the power switch near the volume potentiometer. For larger circuits, you may want to use 2 copper layers and route the traces on both sides of the board. It's also a good idea to label the components so that you can see their labels when complete. Creating a PCB layout is one of the most important aspects of designing an electronic device. It allows you to place electronic components on the board while securely connecting their terminals. Without a proper PCB layout, your device wouldn't work. While engineers spend hours and even days creating the perfect PCB layout, anyone can learn to design the right PCB layout. After all, a professional designer can save you a lot of time and money by using the expertise of an experienced PCB manufacturing company. You should also know the size of your board. A good PCB layout must be large enough for all the necessary components. The size of the board will depend on the functionality and size of the final product. Because electronic products are getting smaller every day, this aspect of PCB design is increasingly important. Moreover, you should estimate the size of the PCB. Then, consider the size and shape of the enclosure. In some cases, multi-layer circuits or high-density interconnects may be required. How to go from PCB schematic to board layout. If you're designing a circuit board, you may wonder how to go from PCB schematic to board layout. After all, the PCB schematic is the basis for the board layout. As such, it's important to ensure that you follow the design rules and seamlessly import any changes made in the schematic into the board layout. Altium Designer can help you with the synchronization process, as it includes design tools that keep the schematic and board layout in sync. And with Altium Designer, you can eliminate the need for an external schematic capture program. Before starting the layout process, it's a good idea to review your PCB schematic. It will likely undergo several revisions before going into production. Checking it now can help you avoid surprises during the board layout. In addition, it can help you find duplicate circuitry and parts that you may have forgotten to remove. Regardless of your background in electronics, you'll benefit from the extra attention to detail. Besides that, a PCB schematic is a great way to avoid rushing through a design stage if it's not completely final. CAD software works to convert a completed schematic into a realistic PCB layout. In this stage, the schematic consists of component footprints, rat lines, and electrical connections between components. A designer then arranges these components and utilizes the rat lines to draw traces, vias, and copper pores. We identify a via as a small through-hole carrying an electrical connection to another layer of the PCB. It may also serve as a thermal via that connects to an internal ground plane. PCB layout capabilities. PCB layout is an essential aspect of electronic manufacturing. If not done correctly, it can result in electromagnetic interference, conflicts between components, limited board functionality, or even complete product failure. Improper PCB layout can be costly and cause delays during the manufacturing process. A professional PCB layout company can help you avoid these problems. Below are some of the key factors to look for in PCB layout software. Let's take a closer look. PCB layout software enables designers to simulate layouts to ensure the right placement and routing of components. By calculating the optimal length for conductive tracks, engineers can optimize the board layout and ensure the proper placing of components. For example, the length of the conductive trace affects the amount of radiation a device will produce and its susceptibility to electromagnetic interference. In addition, the longer the conductive track, the greater the chance of interference and quality impairment. A good PCB layout software allows designers to simulate the length of the signal track. With its advanced layout capabilities and collaboration features, PCB Design Solutions can streamline the design process. The company's multiple teams can use the software to consolidate inventories, component orientations, and manufacturing requirements, accelerating the development process. In addition, Expedition uses industry-approved mathematical algorithms to enable designers to easily view and modify part libraries with the appropriate dimensions and orientations. It also calculates footprint dimensions from dimensional data and builds standard SMT library parts in minutes, which can help minimize time to market.